So that's that, and off we go. All right. So if you walked in, you got a little extra sun than I did, and I'm pretty jealous. It is absolutely gorgeous out. Nice weather is on the way. All the more reason to continue to do what you do every day, or here anyways, come to class. Send some emails with questions, print out worksheets ahead of time, buy a study guide. Basically, keep the motivation going, all right? This should be showing up. No, yes, no, yes, no, yeah. It always wants to misbehave here. Let's see if I can do one thing really quick. No, I really can't. So, oh well. Sorry, I want to make sure this is recording. All right. Now that I've wasted enough time, let's dive into this. Radian measure. We started this. We defined this as, right? We went over this radian. Yeah. So if I took some steps, I used the number 4, and I walked in a circular manner, not around a full circle, but partial circle. So we call that the intercepted arc. Okay. But basically, I'm walking along a circle. And if I do exactly the same number of radius, we call that angle 1 radian. And if you did 8 steps, because it's 2 groups of radius, that would be 2 radians, and so on and so on. And who came up with the formula for this? Or did I put it? Did someone actually relate these? What is the radian measure formula? Or definition? Mm-hmm. Arc length. Arc length. Yep. That I can't control. I was going to say, why do they make it an S? Why do they call slope M? Okay. Good answer. So this is commonly S and R. I don't know why they don't use A. That would just be a good choice. But yeah, it's not. So with no further ado, we haven't done any of these, right? All right. All right, so obviously you see 3 columns here, and first column is titled central angle. So we're going to basically just state what the angle is. Second column is arc length. And the third column is radius. So we're just going to practice applying the formula. Which I'm going to remind myself right over here, theta is S over R. Theta radians, not degrees. That's not how you, nope, would not work for degrees. But this thing called radians. All right, so let's do this. S is 56, R is 7. 56 divided by 7, 8. That's it. Done. Do we put a degree symbol? No, because that would be degrees, not radians. No units with radians. And I believe I mentioned that, but just to kind of go back to this one more time. Arc length I can measure in steps, feet, miles. Radius would be measured in the same unit, so the units end up canceling out. It's considered unitless. So you literally just say 8. All right, new information. Now we have 2.5 given to us, 2.5 radians. So I'm going to substitute that in for theta. I don't know arc length, so I'll keep it S, and I'll substitute in the radius of 8. And now we just have a pretty simple algebraic equation. What do we do to both sides to get S isolated? Multiply by 8, pick up a calculator, and you would find 20. And this does have a unit, centimeters, since we're using centimeters. Well, I guess the same thing here. Theta is 14 over 3. We do know S. Oops, my bad. But we don't know radius. Oh, this is almost too easy, but maybe it won't be easy in the other examples. I mean, what's R have to be? 3. Don't do any algebra. 14 over 3 equals 14 over, not over 5, not over 2, 14 over 3. I need to change that to make that a little more challenging next time, but that's okay. Actually, why wait till next time? Let's do this right now. Suppose this was 28 over 3. This might, I don't even know. We'll find out. Let's see if this is any more interesting. So 28 over 3 equals 14 over R. All right. Still can solve by inspection, but at least maybe not all of us. So what I really wanted to drive here was this is a fraction equal to a fraction. We call that a proportion. Whoop-de-doo. What algebra do we do? Multiply both sides by R and by 3. So when we multiply by 3, it's going to cancel out here. When we multiply by R, we're going to gain R. So we get 28R. And again, if I multiply by 3 and R on both sides, the R's would cancel out. We'd gain a 3 over here. 14 times 3 is 30, 42. Yeah, and I was going to point that out too. So another thing you can do when you have fraction equal fraction, you can literally just cross multiply. 28R equals 3 times 14. And then we would divide by 28. 42 over 28. Probably throw that in any calculator, even though I probably could simplify it in my head, but hey, good opportunity to just say 42 over 28. Three halves. Inches. So we'd have a 1.5 inch radius, which is definitely possible. So a little more excitement there, not much more. Now we need to find theta again. So always helps to write a formula many, many times, right? So theta is S over R, 28 over 1, 28. That's interesting. Theta is S over R, 4.25 equals S over 1. And that was interesting. Again, why do I keep saying interesting? wow, if the radius is 1, then the arc length is equal to the central radian, not degree, angle. Yeah, it's actually an interesting fact. And so a circle of radius 1, at least right now, we can say is interesting, called the unit circle. Everyone will be getting one of these. Everyone will be studying this nonstop. This is your new multiplication table. You will have a blank assessment. You'll have literally another copy of this on a future assessment. No calculator, no notes. First thing you do is you complete this, and then you turn it in. Probably for the remainder of this class, so you don't forget it. So if it's a multiplication table, multiplication facts are important. This is important, at least in mathematical pre-calculus and calculus. So all kidding aside, I'll remind you that later. A little foreshadowing for actually, we're not too far away. Maybe, I don't know, 20-ish minutes or so. We'll be completing something called the unit circle. And this is something interesting because the radius is 1. All right, anyway, we're not quite there yet. And we're actually there's something interesting here. I mean, it's interesting because it looks scary. So that makes it interesting. Second thing that's interesting, before I go any further, does anyone recognize that formula? 2 pi r, cool. So you've seen it in your past. Does anyone remember what it means? I heard area of a circle, but warm. Circumference of a circle. What's circumference? Is it a part of the circle or is it the entire time around? Okay, so what we're doing, there's something magical about to happen. We're not just going, like my story build up so far is like I've taken 4 steps or I've taken 8 steps. This is walk the entire circle, bro. Walk the circumference. And the next thing that's interesting is what I'm doing here is showing it's not going to matter what the radius is. All right, let's get to the spoiler and then I'll come back to that one more time. What is the angle in radians? Theta equals your arc length. This happens to be an entire circle divided by radius. If my radius was 4 steps or 8 steps or 1.6259389 inches, what's going to happen? It's going to cancel out every time. And this is a massive fact. This is a massive fact. It's so massive, it has to go in to this box. 1 rotation around a circle is definitely 360 degrees every single time, regardless of how big the circle is. That makes sense, right? So I'm going to do a circle. What did I just rotate? 360. Now, you would say the same thing if I did a circle around the state of Rhode Island. Might see you in a week or two. But I say, how much did I rotate? You rotated 360. I didn't walk the same steps, but that's not what I'm saying. I'm asking, what did I rotate? At the end of the day, you've rotated 360. So the size of the circle, the length is not what's in question here. It's the rotation. 1 rotation is 360 degrees and is 2 pi radians. Must know fact. And actually, even more important, I mean, this is a good one, although we can kind of simplify it because you have a 2 pi and you have an even 360, we're going to smack everything with a division by 2. A half a rotation is 180 degrees, is pi radians. This literally becomes the gold standard. Next, as of right now, big fact to know. First one is the definition of a radian is theta is S over R. Second big fact is that half a rotation, while that's important, and I like to say that a lot of times, is 180 degrees. We're earthlings, we definitely understand that. Just say that's pi radians. Right? This now allows us to take universal alien way of measuring angles and make them work here on Earth. That gold standard right there allows us to convert degrees to radians. Now, I'm actually just going to do it, and then I'll come back to this box. 15 degrees. I change the degree symbol, and I put this little abbreviation. And I was taught, I think it was some type of chemistry class, that if I want to go from one unit to another unit, I write this unit down in the denominator. And you write what you want in the numerator, because these cancel out and this will survive. So my answer is going to be in radians. But now I just have to make sure whatever I write has to be like equivalent. So that means the gold standard, 180 degrees, is pi radians. Ignoring all the labels now, 15 times pi is 15 pi on top of 180. And if I forced you, I know you would be able to simplify it. You wouldn't want to, and I don't want to. I'm just going to go to my calculator again. 15 on top of 180. 1/12. So that's going to make 1/12. 1 times pi is pi. At the end of the day, pi over 12. You take degree, you get rid of degree, you go to radian. These are going to cancel out. And at the end of the day, you're going to multiply by pi over 180. That's really what's going to happen every single time. It doesn't matter if it's 15 degrees or 37 degrees or 90 degrees. It's like 60 degrees outside. You're always going to have a 180 down there because you want to cancel the degrees. You're always going to have a pi on top. Degree to radian. Hey, stop it. Okay, back on track. Let's go the other way. Again, I do this because I find it helpful. I don't feel like this is hard anymore. If I'm studying formulas and then like I go home and I'm like, oh wait, I gotta remember like degrees to radians is this one. Like you don't have to memorize that. You take a strategy that works now, other math classes, other science classes, which just says ditch the label. Go to what you want to. Those are going to cancel out. This will survive. And then I only have to memorize the gold standard, that 180 degrees is pi radians. So let's look at what we got. We have 7 pi divided by 18 times 180 divided by pi. Immediately, I just love doing this. See you later, pi. You're gone. And while I could absolutely go to my calculator, I also recognize this is probably just quicker. 18 goes into itself once and into 180 10 times. The only things that have survived is 7 times 10, 70 degrees. If we have radian, there it is. Just so it looks uniform. Boom, boom. There we go. Start with radian. At the end of the day, you're going to end up multiplying by 180 over pi. Cool. And before I move on, that's radians. So a few lessons ago, beginning of the class, who's had trig, who had it, doesn't matter, it really doesn't. If you've never seen radian, or even if you have, hopefully you have a little better understanding now about why we use 360 on Earth. You can let it go from here, and I will too. I'm not going to bring it up anymore. It's just cool little knowledge. It motivated the lesson. It's not something I'm going to ask on a test. That was just supposed to be kind of interesting and fun. But it felt natural to talk about making steps, making an angle. And you told me the Wikipedia, the textbook definition of what a radian is. I didn't tell you, you told me. Very human. We applied it, and then we applied it to the general case, all the way around a circle called circumference. Is 360 degrees, is one rotation in terms of angle, not steps. Walking around Rhode Island, walking around this room, 2 different amount of steps, but I'm not talking about steps, I'm talking about rotations, is 2 pi, and then we divide by 2, you get 180 over pi. Definitely a must know. How to convert? Not really that hard. And we're done with radians. Onwards we go. Angles of rotation. Give you a minute to write this down before I talk at you. You can pause from you can pause at this point. We're eventually going to write it, but I'm going to talk those out for a minute. Ooh. Please add this. I apologize. I meant to. I'm mad at myself because I really read that twice. Last night I was like, oh, I'll change it in the morning. I'm tired. This morning I was in school just making sure, ready to go for you guys. I was like, oh, I got to change that, but I'm like, I'm eating lunch. I'll do that before I start class. And now, yeah, it's actually massively important that we mention that it's a positive x-axis. All right, so I don't mean to baby you, but I'm just going to kind of baby you for a minute. So I'm assuming you've all seen angles and triangles. We've done it here. If you've not thought about angles outside of triangles, here we go. It's common in science and math to think about this. Here's the positive x-axis from your point of view. This would be the negative x-axis. This would be the origin. That would be the y. All right, but I want to focus on the positive x-axis. So we have something like this. Boom. Maybe like a clock hand. I'm at 3 o'clock. And if I say rotate 90 degrees, actually, maybe you already know, but a choice has to be made. Because one way to rotate 90 degrees would have my fingers pointing towards the floor or toward the ceiling. So there's a choice to be made. The choice is positive means up to the ceiling. Why was that choice made? Probably because our ancestors studied the sun, which rises and sets and rises and sets over and over and over again. So anyways, that's my little Jeopardy potpourri knowledge of the day. Standard position, we start on the positive x-axis. If I say rotate 90 degrees, we rotate 90 degrees. We stop. That's called our terminal side. And the vertex is the origin, like really the bending point, 0, 0. If I say rotate negative 30 degrees, you rotate, well, you start here, you rotate downwards, not to 90, but you estimate like 30 downwards. We call that a negative angle. It's not like anything else than a direction. The negative sign literally just means a direction. All right, so now we'll practice sketching some angles in standard position. We're going to do these one at a time. One of the vocab word did pop up there called reference angle. So we're going to sketch the angle. We're going to sketch the quadrant. If you forgot how to name your quadrants, you can't after this lesson. You must know your quadrants. I don't mean, again, I'm not trying to baby anyone, but then sometimes, like a few semesters ago, I was teaching this class. I didn't mention quadrants. I just assumed everyone knows 1, 2, 3, 4. And then that was a bad assumption. So no judgments. If you know it, good for you. But my expectation is everyone knows it. So we're going to go review quadrants and finding this thing called the reference angle. So one at a time, 135. We need an XY sketch. And here's my initial side. Right there, beautiful. And now it's like a spinner. I have to rotate it, 135. Since it's positive, we must start moving it towards the wall, the ceiling. Now, there's some other common things we as humans know. This would be 90 degrees. This is 180 degrees. This would be 270 degrees. And all the way back around would be 360. So this is kind of funny, the way I've drawn this, because it actually is where it should be. We're going to draw past this. And I'm just looking for an estimate. Now, if you just threw it right there, that's a bad estimate. That's like 95 degrees, or maybe 100. And if you drew it like way over here, that's like 179. So like an estimate. Not perfect, but bing.
Is that because we only really care what quadrant is in?
I just think it's a good estimation scale. But yeah, we do really care what quadrant it is in. Yeah. And so that is called quadrant 2. Brief reminder, if you forgot your quadrants, we use Roman numerals and they go in the same direction as the sun. For that reason. It starts here when you wake up on the horizon at noon, nighttime, we're sleeping, and it's back. So 1, 2, 3, 4. Anyways, no. So this terminates in quadrant 2. Sketch an angle in standard position. Initial side, terminal side, great. Name the quadrant 2. Reference angle. This is worth watching for a minute, not trying to write. The definition said, take your terminal side, look at the x-axis, all of that's the x-axis. And there are actually 2 angles that are made. This angle, I don't want to use green because I've got it over there. I'll go with blue. This angle and this angle. So kind of blue and yellow. Acute means more than 0, but less than 90. Where's the acute angle? Blue or yellow? You got to know it. You don't have to go crazy. You just have to know. This is 90, letter L. So if you go more than L, that's not acute. It has to be like a small. This is the reference angle. And furthermore, we must figure out what it measures. Now, I'm going to add this to my diagram. If you missed what I just added, I'm actually going to show the rotation. And I need this part. I bet you know it. Second hint. I know this part. I don't know this other part, but I know the total of the 2 is 180. 180. So what is this number? 45. How do you get that number? You subtract, right? It's like, bro, you have $180. You pay me 130, or I'm taking 135. What do you got left? Right? Part of it. So you just subtract it from the total, which I could go to my calculator, but I'll just do it this way. It's 45 degrees. And we've done it. Angles of rotation. That's not bad. Initial side, terminal side, reference angle, quadrant. Let's go. Negative 300. That's 0. That's where we start every time. Negative. Don't move your fingers towards the ceiling. We're going towards the floor. So now I'm just going to go this way then. Well, that would be negative 90. This would be negative 180. This would be negative 270. And all the way back around would be negative 360. Push it towards the floor until you get to there. So we're going to go past that. We're going to go past that. We're going to go past that. And we're going to end in quadrant 1. And we're going to show it like this. Boom. There's the rotation. There's my terminal side. There's the quadrant. I want you to think about this independently for a few seconds. What's the reference angle? Multiple choice option A, 30 degrees. B, negative 30 degrees. C, 60 degrees. D, negative 60 degrees. A is positive 30. B is negative 30. C is positive 60. D is negative 60. Close your eyes And you're going to do a hand vote. I'm just curious. No judgment. I'm just kind of curious. All right. Put your hand up if you say A, positive 30. Hands down. Put your hand up if you say negative 30. Hands down. C, positive 60. Hands down. And D, negative 60. Cool beans. All right. So 2 of us got it right. And the correct answer is, what's the definition of acute? It has to be more than what number? Are negative numbers more than 0? So if you voted negative, and less than 90. Well, both 30 and 60 are 90. Some of us said 30, some of us said 60. 2 of us said 60. How do we think about this? Well, let me do the highlighter. I'm not going to do the highlighter all night, but since we're kind of still getting there, that's the x-axis. This is the terminal side. Which one of those angles is acute? That one right there, the mouth. Boom. Now, we can think about this a lot of ways. The easiest one is if I've gone ignoring the sign, because it really just means direction, but if I've rotated 300, 60 more would have completed it. So there's one answer. Or as I was doing this, I could say negative 90, negative 180, negative 270. How much more do I need to rotate? I need to rotate. I got to stay on this one 30 more. So this is 30, but that's not the x-axis. This is the x-axis. So it's not hard. It's just practice. And you talk it out. And if you make a mistake, you say, that's okay, I made a mistake. Learn why you made the mistake. If you said negative, now you're like, damn, I'm not going to say negative again. I learned from your mistakes. But I see a question. Just give me uno second. This right here is your reference angle. I don't want too many arrows because then it gets messy. So I'll just say reference angle. And the key takeaway now is it's always positive because that's the definition of acute. And it's always more than 0, but not more than 90. So it can't look past a right angle. It has to be like whatever. Sometimes they open that way. Sometimes it doesn't matter. It's like whatever the angle is with the x-axis. Always positive. Yep. Regardless if you rotate something. So the rotation was negative. The reference angle is always positive, regardless. 400. Let's go. Boom. Boom, boom, boom. All right. Now I'm not going to baby you because I know you know more. I hopefully you know 90, 180, 270, 360. Bro, 400 is definitely more than 360. What does that mean? It means we're going to go more than one circle. So let me not waste time here. I'm just going to say I'm starting at 360. I know, I'll show you what I mean in a minute, right? But I know I'm already going to go around once. Now 90 more than that, check on the calculator, 450. And I think I'm good because I am good. I need to rotate 400. Here we go. Start on the positive x-axis. Open up towards the ceiling. Go all the way around. And some. Once again, we're in quadrant 1. Note to self, when I rewatch this video, make something end in quadrant 3 or 4 next time. Yeah, everything's been 1 or 2. But okay. That's not a takeaway. Like literally it can end anywhere. And reference angle. I'm going to go with gray. Boom. Nope, I don't want that. I'm just going to go bing, bing. This side, I can travel the x-axis, but that's an obtuse angle. Go down your terminal side, go to the x-axis. That's literally if you're having a hard time, like some students have a hard time saying, I get it, I just can't find the reference angle. So not to drag this on forever, that's a good opportunity for office hours as well, but just literally acting it out so you can see. If I can find that marker. All right, so if you have an angle, actually, I'll do something in quadrant 3. So I'll be like, all right, boom. So if you're not sure how to get the terminal side reference angle, take your pencils, trace your side, and then say to the origin, and say, if I go along the x-axis that way, is that acute? No. So you would go this way. This would be your reference angle. So I just rotated 205 degrees. What's the reference angle? This is 80. How much more gets you to 25? Oh, reference now. I'll just say reference. That's what I meant to do. So you found a quadrant 1, you found a quadrant 2, you found a quadrant 3. Let's just overkill this. Negative 37 degrees. Start, rotate towards the floor, but that's too far. So something like this. Our rotation is negative 37. What's the reference angle? Positive 37. There you go. It's that angle right there. Here's your side. That's it, 37. It's a little bit of a mind bender. I'll say it one final time, and then I'll talk one-on-one with anyone who wants it more direct. Let me hear what you're struggling with. But if this is the rotation, that's what we're thinking about. And in math and sciences, things rotate. Many, many things rotate for a lot of variety of reasons, not just tires. But a reference angle is always a positive angle. And there's a reason that's not super exciting, but there's a reason for it in a future lesson. So onwards to radians. And students go, oh man, this is where I need to pay attention. This is so easy. Like, I already know that's a quadrant 3 angle with a 1 pi over 8 reference angle. And it's not that I'm better than you. It's that friggin' easy. And I say that every time I teach this lesson. No one believes me when they hear it. You're probably like, no, I'm already scared. There's fractions, there's pi. I got what? Here we go. We're going to do a few of these to get rid of the fear. 0. What's the gold standard number in radians? What I highlighted in yellow, which is how many degrees? Which is half a rotation. So let's label that pi. What number's in front of pi? An invisible. That guy's like, he's a weird teacher. You're right, bro. How do we make 1? Like this, or like this, or like 2 over 2 is 1. 3 over 3 is 1. What else is 1 that might be mad helpful? Look at the radian measure we need to draw. 8 out of 8 is 1. That's it. So where's 9 out of 8? A pinch past it. In quadrant 3, how much more past it? 1 out of 8 more. Simple. But if I lost you, gold standard. It is. Like, that's it. It's 0 and pi, 0, 180. But that's a number 1. Why do we choose 8 out of 8? Because we're going to measure some amount out of 8ths. So let's go right here. What is this out of 8? 4. If this is 8 out of 8, then half of it is 4 out of 8. And if this is 4 and that's 8, what's this? This is overkill. I don't need this much for the problem, but just to since we're here, why not? What would this be out of 8? 4, 8, 12. And what would this be? And what's 16 over 8? 2 pi we said is a full circle. Bro, this is magical. Boom. Rotate 8 out of 8. Don't go past 12 out of 8. We just want to go 9 over 8 right there. There's 9 pi out of 8. Now, if you have 8 out of 8 and it became 9 out of 8, what's this reference angle? 1 pi out of 8. One more, so just pi out of 8.
Wait, how did you just get the 5 8?
You're going to tell me. What was this rotation? What's this rotation? Right here, what's this rotation?
The 9 pi over 8?
Perfect. Hold that for a minute. Halfway around is how many?
4.
Nope.
4 8.
Nope. It's right here.
8 over 8.
Halfway. There's a lot of different halfways, so I'm with you. So right here is 8 out of 8. How much more did we go?
Oh, okay.
1 right there. That's the extra we went. Cool? Seeing it? We're going to skip this next one. If you already wrote it, we'll come back to it. I just don't like it as the second example. Zero pi every single time. What number's in front here? 1, which is also 2 out of 2, 3 out of 3, 8 out of 8. Not going to be helpful. What's going to be helpful? You guys got this all day and night. Do what's helpful. You're not going to find this in a YouTube video. You're not going to find it in a textbook. Probably not going to find it in another professor's class. But do what's human. Do what's helpful. That's 1 pi. Cut it in 21sts. Where's 20 of them? After or before it? This one we can do a good estimate would be pretty close because we're almost there. Think of that. If there was 21 parts, this was like a calzone. I don't want to say pizza, but this is like a calzone. Windshield wiper. I don't know. And we basically are cutting it. If you started here and you rotated around, you'd have like a calzone. Now I'm going to draw a calzone and I'm hungry. And I want to see it because you're like, what is he talking about now? Calzone. Right here, right? Yum. Calzone. And you start here and you start eating it all the way around. You would have ate 1, I'm not going to say pi, 1 calzone. But if we cut it into 21 out of 21 parts, that's still 1 calzone. I ate 20 out of 21 and I'm just full. I had that planned. I didn't just make that up. But the year I did make it up, I was like, I don't know where my brain goes sometimes, but I'm glad my brain went there, and I've used that for years. And I see students with one, they're like, calzone. Not the nickname I really wanted, but that's okay. I'll take it. All right, practice time. That means you do. Turn to a neighbor, check with them, talk it out. Have one-on-one if you need it. Let's sketch out of 6, 7 pi out of 6. And let's stick there. Do a new sketch. Out of 6, 11 pi. You're doing both of these, and both of these, and both of these. Three pi. I'm going to take this off for a minute. So if I have a conversation with one of you, it's not. So there you go. See, the reason I like that one is that it gives you learn how to skip count. 3, 6, 6. So where's 11? Past 9? That's not. Yep. You getting this? Yep. So yep. So 11 pi is not quadrant literature. So 6 out of 6 is perfect. What's half of 6? 3. The reason I like that number is because it teaches us how to skip count on like 11. So 3, 6, and then the bottom part would be 9. And then all the way around would be 12. And that 11 is between 9 and 12. So it's a quadrant. 4. So over here needs help, walk out. Good. If it's just one, okay, so throwing a little curveball at you. Did anyone figure out 3 pi? Yeah, like I left that one a little bit vague, but that's 1 pi, and the denominator is 1, so we should probably just keep it 1. You get what I'm saying? Like we don't want to change the denominator, but if you want to put a 1, then you can do 1 out of 1. Where's 3 out of 1? So that's 1 out of 1. This would be 2 out of 1. And now the out of ones is effing with my mind. I'm just gonna go like this. 1 pi, 1 calzone, 2 calzones, 3 calzones, 3 pies. Maybe we should just call the pies and go calzones. 3 calzones, 1 calzone, 2 calzone, 3 calzones. There we go. 3 pi is that. It's 1.5 times around. Literally, probably some common thing to do in the real world. It's going to rotate a full and a half more rotation. Getting by this. Good.
I just don't understand that. Just
Rotate towards the floor.
okay.
Instead of towards the ceiling. Get this. Yep. Mm-hmm. So did we go all the way to 12? How much are we sure? How much? So 1 pi is 6. Right? If you're working, cool. I'm just going to start talking these out. Sorry, I'm in the background. I just watching the clock a little bit. So walking around, everyone's leaving today, getting a good vibe of, we're looking at the denominators. Cool. Man, this was scary a few minutes ago, right? So you're like, ah. Hopefully it's a little less scary. I'm not asking you to be perfect, but if the light bulb hasn't really gone, it will. 0, 1 pi. 1 is 6 out of 6. Next, that's 7. So me, I know it's a scoop I. But if you don't know that, then you take the extra 5 seconds and say, all right, half of 6 is 3. This teaches us what we're going to skip count by now. And you skip count 3, 6, 9, 12. You double check. That simplifies to 2 pi. Everything's ready to go. Where is 7 out of 6? Right there, in between 6 and 9. Right there. That is in quadrant 3. Calzone. Did you eat more than 1 calzone? Yeah. Did you eat 2 calzones? No. How much more did you eat? Reference angle. Well, 6 to get this. Oh, I ate 1 more slice. I ate a pi out of 6 more. And you can check your answer by saying this plus this makes the total rotation. Next one is 11 pi out of 6. Good news is we're going to have the same values here. 3, 6, 9, 12. 11 is not quite all the way. This right here is my reference angle. How do I think about what that size is? Did you eat 2 calzones? No. How much was left over then? 1 pi out of 6. Right? They're not the same story. I get that. But it's the same logic. You ate more than 1, so you just add that in. You didn't quite eat 2, so you just figure out the little leftover there. 3 pi we already went over, but just so it's on the video, in case you're like, you know, I hear this all the time. I got it in class and all of a sudden I was at home and boom. So you find this part of the video. 0, pi. And here's the thing, not to overkill it. We just want to say, yo, no fractions, cool. Let's leave that. So 1 calzone, 2 calzones, 3 calzones. So what did I really just do? I went a full time around and then a half time around. And my terminal side would be literally on the negative x-axis. Is that in a quadrant? We can fight about this, but the answer is no. So it is called a quadrantal. I hate that. I just hate it. I feel like I'm saying it wrong. Angle. Anytime you land not in a quadrant, so that means either here or there or back at the beginning, there is no quadrant. That's it. I don't want it's just that's it. And there's no reference angle. Because a reference angle for the last time is always positive, is bigger than 0, and strictly less than 90. 90 is not an acute angle. 90 is a right angle. So there's no reference angle. There's no quadrant. We would just say it ends on the negative x-axis. That's a good answer. That's a perfect answer. Negative 8 pi over 5. I left that one for you to figure out. If you didn't get it, it's all good. You tried. 0 pi, but probably want to call that negative because we're going to rotate this way. We're going to rotate opening towards the floor first. And I do want to use fifths. And this was still a little bit, 8. So let me just go. What's half of 5? 2.5. And remember, I'm going to get here first. So negative 2.5. And that's what we're skip counting by. So negative 2.5, negative 5. What's this? Negative 7.5. And then all the way around would be negative 10 out of 5. Perfect. I like to make sure, especially in a new example with decimals and negatives, this still makes a negative 2 pi, which just means rotation. Cool. Where is 8? Let me rephrase that. Where is negative 8 pi over 5? Right here. That is definitely in quadrant 1. What's the reference angle? What gets us? What completes this? What would finish this? Negative 2.5, positive 2.5, 2.5 pi over 5. It's positive always. We need 2.5 pi over 5 more. My bad. Right. I'm looking wrong thing. Thank you. Just making sure you're paying attention. I was looking at this, not the actual angle. The actual angle, my bad. I got you. Thanks for screaming this time. This is the rotation. I was looking at the wrong thing. So we need, you're like, damn, I was just getting it. 2 pi over 5. How many people had that? Yeah, okay, good. My bad. I'm only human. Pi over 2. 0. Pi. 2 out of 2. Oh. Pi over 2. There we go. A 90-degree angle. Well, that's interesting. Hang on. I'm going to write that down. We'll come back to that. You can write this down later. But there we go. These are so common, maybe we should just learn them. We're going to end the lesson there. So when you see this later, be like, okay, got you. 90 degrees is going to be pi over 2. And therefore, I'm not even going to draw another picture underneath there. Why I gave us that. 1 pi over 2, 2 pi over 2, 3 pi over 2. I'll change the color at least. So we'd go, boom. I'm foreshadowing, I already did foreshadow. We're going to end shortly. They're going to be called landmarks. Those are going to be like important, like landmarks are important. Like your multiplication numbers. Your multiplication table has landmarks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Typically it doesn't have 13 and it doesn't have 2.5 and it doesn't, right? So those are the landmark multiplication numbers. We want landmark degrees 0, 90, 180, 270, 360. 0, pi over 2, pi, 3 pi over 2, hooray. And we'll add to that momentarily. Special right triangles, 30, 60, 90, 45. Okay. Was that all of them? Yep, cool. I'm not going to do any more degrees. Degrees are usually not the issue, and I hope now radians is not the issue either. It's up to you if you want to rate this part. I definitely would recommend the blackboard. So, coterminal, bottom line up front. Same starting position, same ending, so they overlap, but it's not the same rotation. What? Just not fighting that at all. So I'm gonna just doodle for a minute. That means don't write it down. Here's my little four-legged friend, one of many. Rough, rough, rough. And this is actually not a true story, but they're allowed, I have a fence yard so they can run free, but imagine that they were kind of like anchored on a leash somehow, like on one of those run things. So, and a lot of energy, so gonna run around in a circle. And the dog ended right there, like chasing a squirrel somehow. But I'll tell you this, the dog did not rotate 10 degrees, even though that reference angle is 10 degrees. How did that possibly happen? How could you start here, end there, but not rotate 10 degrees? Go ahead. And a little bit more than 3. You got it. You got it. So what did the dog do all together? Not 360, but 370. Went around and then ended there. Cool. Turns out that's not what the dog did. The dog did not do 370. The dog did not do 10. Tell me another rotation. Tell me the number. You're warm. You're there. Now, tell me what it did. Negative 350. And I'll let this story go. 10, 370, and negative 350. And we could probably do this over and over again. No pun intended there. Over and over. We could do this over and over again. No pun intended. Literally, though, we could do this over and over again. Like keep adding and subtracting 360. And my main point is 10 degrees, 370 degrees, and negative 350 are coterminal angles. They start and end in the same position. Obviously, the dog did different things. That's it. End of story. In degrees, bottom line, you add, in case anyone did write the opening paragraph, coterminal angles have the same initial and terminal sign, but vary by either adding or subtracting 360 degrees or adding or subtracting 2 pi radians. So if you're just getting to the main point, you add 360 or subtract 360. You add 2 pi or you subtract 2 pi. That's it. That's it. I don't know how else to say. one other thing before we kind of almost end this night, a little bit early for a change. Yeah. This is just awkward English, so I'm just addressing it. Least positive and greatest negative. We're going to see in like 2 minutes that this is properly worded, but it can catch us off guard. So before we end here, if these are two secret numbers, which is the greater one, A or B? I'm not telling you what they are. They're secret numbers, but one is greater. One on a scale is going to weigh more. Give me an example where it depends then.
Where's the rough? Like, let's say the origin is closer to A, then like it's A would be like less.
Where?
I don't really know where it's getting at. Yeah.
Okay. So where?
So if zero's like to the left of A, then
Okay.
A would be smaller than B.
So B would be greater. B would be greater.
Assuming it's positive.
Oh man, there's a lot going on here. Let's go through all of these. So if B positive,
Yeah.
why did that take like 10 minutes to show up? Okay. So both A and B are positive. Who's greater? Okay. I guess 0 could be in between them. So A would be a negative and B would be positive. Who's greater? Really? There's no. Then you just don't know what greater means. A positive is always greater than a negative. Always. A positive on a scale, like marbles, 3 outweighs 2. Anything on the right, if we're going to go back to this, outweighs a lesser amount of marbles. So if this was 3 and this was 2, 3 is greater. The scale would be this balance. If this was whatever. Now, how do we think about negatives? Not marbles, but balloons. They undo a marble. If I have a marble and a balloon, a positive one and a negative one on the same side, nothing's happening to that scale. So let's think about balloons. If you have a balloon and you have a marble, still greater. The scale B will always push down any amount of balloons. And now, if we're here, like, who's greater? B still is. B is always the greater number. I didn't expect us to have that conversation. Greater numbers, all I was expecting, this is cool though. We learned something. It doesn't matter where you are on a number line. Whoever's on the right is bigger, is the greater number every single time. -8, what's greater than -8? -7. What's bigger than that? -6. 0 is bigger than every negative number. 1's bigger than 0. 100's bigger than that. The bigger number is on the right. Doesn't matter where we are. Okay. Next, we can answer this. We have positive, least positive. What the heck does that mean? Remember the dog story? 10 degrees. 10 Then someone said 370. And then someone said negative 350. And we can continue. All right, I already forgot my joke, but we could continue to do this all along. But which of these is the least positive? Well, that's negative, so you're out of the running. That's the least positive. Because you can continue to find more positives, but this is the smallest positive. Usually what we want. That's how we simplify angles. We pretty much want to bring them down to either the least positive or, now, negative numbers. I will beat this to death. I'm going to come up with one more coterminal angle. So I'm going to take away another 360. Oh my gosh, take away 300 would be 650. Then 50 more would be 710. I want the greatest negative. Here's two negative numbers, but the greater one is always on the right. So this guy. We basically want what I said here. The two numbers as close to zero as you can possibly get, but the positive one and the negative one. So zero, like that's it. There's no other way to get that. Does that make sense? As I said, awkwardly worded, and there's no judgments. I thoroughly enjoyed having that conversation. All right, mad simple. Find the least positive and the greatest negative. 520, is that more or less than 360? So let's start taking away. Pick up a calculator or just do elementary school math. Oops. And we get 160 degrees. Because I know if I take away another 360, I'm not going to be positive anymore. This is my least positive. But since I want my greatest negative, again, very awkward phrase, I said that. But ultimately, this is all we need to do. Take away 360 one more time, and we'd get negative 200. And that's your greatest negative. Okay. Negative 487. Is that more than, this is these freaking words. What basically happened? Some dog ran around a circle clockwise more than once. That I know for sure because it's more than negative 360. Okay, so let's start adding 360. Negative 127. I know that's going to be the greatest negative because adding another 360 to that's going to get me into positive land. Just turn on my little calci, plus another 360, 233. Least positive. I think there's one homework question that says list 5 angles or something like that. So you just keep going, right? It's not going to say greatest negative or least positive. It's just going to say like give 5 coterminal angles. So add 360 and comma, whatever it says to do. Radians. We add or subtract 2 pi. Now, if you need to do this, do this. But if you can do it in your brain, you know it no better than me. You're at my level. This is all my brain's doing. 4 out of 4, 8 out of 4. So I know this is bigger than one rotation. Do you see? Like, because I'm trying to figure out, do I add or subtract 2 pi? I did a quick thing in my head. I said 4 out of 4. So go another. That would be 8 out of 4. So I know I need to start subtracting 2 pi. And watch how I'm going to subtract 2 pi. not with the calculator, because I can do it quicker than a calculator, and so can you. We need to subtract 2 pi. You just have to rewire how we think about the numbers 1 pi and 2 pi. And the clue every time with radians is the denominator. So instead of saying 1 pi, I'm going to say 4 out of 4 pi, 1 pi, and 8 out of 4, that's 2. Subtract 2 pi, 13 minus 8 is 5 pi out of 4. This is your least positive. Take that. Subtract another 2 pi. And 5 take away 8 is -3. There's your greatest negative. Sixths, it's negative. So -6 out of 6, -12 out of 6. That's more, so I know I'm going to start adding 2 pi. -27 pi out of 6, add 2. That's 2. 12 over 6 is 2. And let's see, adding 10 would bring me to -17, then adding 2 more would bring me to -15. Wait a minute. I already know 12 is 2. I need to go again. Add 12 pi out of 6 again. And I'm at -3 pi out of 6. And I know if I add 12 again, I'm going to get bumped into positive world. So this is going to be our our greatest negative, but we should reduce it to -pi over 2. And I could have done that from the beginning, okay? I could have done that from the beginning. When I wrote this last night, my dogs were jumping all over me, so I made some silly mistakes. And I proofread it, and I was like, didn't catch this one. But this, we could have reduced it from the beginning. But even if we didn't, there we go. All right. The idea, what I wanted right here is an example where we needed to do it twice to get here. And now we're going to do it one last time. We're going to add 12 pi out of 6 to this. You would get 9 pi out of 6, which would reduce to 3 pi over 2. And by the way, this would be our least positive. Moments ago, I had those red numbers there. A few things. Let's end this conversation. Can we do a quick check that this is true? Well, if we know our landmarks, rotate -pi over 2. We want our brains to think of that as easy if I said rotate -90. Boom. There's my dog. Rotate 3 pi over 2. We want our brains to know it as quick as saying rotate 270. 1, 2, 3 pi over 2. Yeah, it worked out. Coterminal. Multiple things just happened there. If you caught it, you know it as well as me. Common angles to recognize quickly. 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, the quadrantal angles and their equivalent radian measure, 0 pi over 2 pi, 3 pi over 2, 2 pi. It was a fun conversation, at least for me. I hope you enjoyed some of it. But at this point, you know, like if I'm teaching elementary school kids, when we build the multiplication table, we're taking marbles in groups of 3 and then 2 groups of 3, and we're literally like exploring it. But then at some point it's like, okay, bro, go home, and 2 times 3 is 6. And you got to start to do that. You got to just say, all right, that was fun. I get it. But these are the common ones. We need to know them. 30 degrees. How can I get 30 from anything here? I could take 180 and divide it by what? 6. 6 goes into 18 3 times, so 6 goes into 180 30 times. So divide by 6, pi over 6. But we don't want to like always coming up with this. We want to eventually say 30 degrees is pi over 6. (180) is pi. What would I do to 180 to get to 45? Here's what I would do. I would divide it by 2 to get to 90. So I would divide it by 4 to get to 45, pi over 4. And if dividing by 6 makes 30, if I divide by 3, it'll make the 60. We didn't get here, so I will save this. And you should be able to do the homework. I was going to open up one more, so that's it. The 3 homeworks are right triangle trig, SOHCAHTOA stuff, radian measures and angles of rotation, you can do it, you can do it, you can do that. Yeah, and right triangle trig. Now, the one question that I know is going to come up, you can view an example, and then I'm going to end, like, I guess we're not going to get out early, but we're going to get right on time. So you should know these 2 triangles from last class. The smallest angle is 30, you put a 1. The largest angle is 90, you put a 2. No matter how you draw your triangles. If I drew it like this, if I put the 60 down here and the 30 up here, you say this is 1 and this is 2. See what I did there? Smallest angle, opposite side is 1. No matter where I draw it. So it can be whatever. Smallest angle, 1. Biggest angle, 2. 90 is the biggest angle. A 1, a 2, a 1, 2, root 3. There you go. Know that triangle as well. And if someone said, what is the sine of 60? You look at your triangle and you say, so opposite over hypotenuse, root 3 over 2. Or you look at this triangle. What's the sine of 60? Opposite over hypotenuse. You're going to get, right? It doesn't matter how you draw it, as long as you draw it correctly. And the 45, 45, 90 triangle. So there's a couple questions in the right triangle trig. I'm looking at it right here. It's like, find sine 30, find tangent of 45, find the reciprocal, cosecant. Remember what the reciprocals are. You're just going the other way. All right. So you got 3 homework assignments. You got this lesson. You got the rest of tonight, which is like 1 minute early. So adios. See you later. We'll do unit circle, the start of next class.